The record heat is officially gone. Temperatures have dropped, headlines have moved on, and most people assume the story is over. But scientists say what actually rushed in to replace that heat is a bigger concern than the heat wave ever was. There is a reason meteorologists keep using the word vacuum to describe this moment, and it is not just for dramatic effect. To understand why, you first need to understand what a record heat wave actually does to the atmosphere while it sits in place. A heat dome is essentially a massive pocket of high pressure, parked motionless over a region for days or even weeks. Underneath it, air sinks, compresses, and heats up. That sinking air also pushes moisture and energy down toward the surface, effectively loading the atmosphere like a spring being compressed further and further with each passing day. The longer that high pressure holds its position, the more energy builds up underneath it, with nowhere to release. This year, that buildup reached extraordinary levels. Late June brought what became the worst heat wave ever recorded across large parts of Europe, with Spain hitting 45.1 degrees Celsius and Germany reaching a provisional 41.5 degrees. The same heat dome pushed into the UK, where Cardiff's Butte Park recorded a June night that never dropped below 23.5 degrees, obliterating the previous record by more than 3 degrees. Britain logged 8 separate days above 34 degrees Celsius this year alone, breaking a record that had stood since 1976. Across the Atlantic, North America faced its own version of the same pattern, with temperature records tied or broken in major cities across the United States and Canada, and Atlantic City hitting 106 degrees Fahrenheit on the 4th of July. Then, in each of these regions, almost on cue, the heat broke. And that is exactly when scientists say the more dangerous phase of the story actually began. Here is the physics behind what meteorologists mean when they talk about a vacuum forming. While a heat dome sits in place, it is not simply hot. It is also incredibly stable, holding the atmosphere in a kind of frozen tension. Once that high pressure finally weakens, whether from a shift in the jet stream or the arrival of a stronger wet system nearby, it does not just gently dissipate. It leaves behind a rapid pressure drop, and the atmosphere rushes to fill that gap almost immediately. Cooler air surges in from one direction, while all the pent-up heat and moisture that built up over the preceding days gets forced upward at once. That collision is the vacuum scientists are referring to, and it is an extremely effective engine for producing violent weather. The United States saw this play out in dramatic fashion around its 4th of July holiday. As the record-breaking heat wave entered its final stretch, meteorologists warned that the very same heat could end up fueling storms right in the middle of Independence Day celebrations. That warning proved accurate. Severe storms tore through New York and New Jersey, downing trees and knocking out power to roughly 250,000 customers in New Jersey alone. In Canada, the heat brought large thunderstorms on Canada Day that triggered widespread flooding and left thousands of homes without power. What should have been a celebratory holiday weekend turned into a case study in exactly how quickly conditions can flip once a record heat pattern starts to collapse. The United Kingdom offered its own version of this same story just weeks later. After a brief cooler interlude, Britain moved into its third heat wave of the year in early July, a prolonged stretch of low to mid-30s Celsius that lacked the record-shattering peaks of the earlier heat dome, but made up for it with sheer duration. Forecasters, the following week, peaking around 35 to 36 degrees in southern and eastern England before thunderstorms were forecast to break the pattern down entirely, ushering in fresher, cooler Atlantic air. That transition point, meteorologists warned, was exactly where the real risk would concentrate. Scientists point out that this vacuum effect tends to be more dangerous, specifically because of how long the heat lingered. Beforehand, a short heat wave that breaks after a day or two does not build up nearly as much stored atmospheric energy, but a heat wave that persists for a week, 2 weeks, or in Britain's case, essentially rotates through 3 separate heat events across a single summer allows enormous amounts of heat and moisture to accumulate in the surrounding atmosphere. When that pressure finally releases, the resulting storms tend to be sharper, faster developing, and more destructive than storms that form under normal seasonal conditions. Similar versions of this pattern have shown up well beyond Europe, the UK, and North America this year. Parts of the southern hemisphere experienced their own extreme heat earlier in the year, with a record-setting heat dome pushing temperatures in Australia close to 50 degrees Celsius, followed by destructive wildfires that swept through remote parts of Argentina and Chile. In several of those cases, the eventual breakdown of the high pressure responsible for the heat brought its own sudden shift, including gusty wind changes capable of turning existing wildfires even more dangerous almost overnight. That detail matters because it shows the vacuum effect is not limited to producing rain and thunderstorms. Depending on the region and the season, it can just as easily intensify fire, risk by suddenly changing wind direction and speed across landscapes already dried out by weeks of extreme heat. There is also a longer, more uncomfortable trend feeding directly into this pattern. Global climate records show that 13 consecutive months once set new average heat records worldwide before that streak finally broke, driven at the time by a powerful El Niño event. Scientists were careful to note that the end of a record-breaking streak did not mean the underlying warming had stopped. As one senior climate official put it plainly at the time, the forces pushing temperatures higher are not stopping, whether or not any individual month or season sets a fresh record. That same logic applies directly to this year's pattern. A single heatwave ending, even a record-breaking one, does not mean the atmosphere has returned to some kind of stable baseline. It has simply entered its next, more volatile phase. Researchers studying why these heat domes are lasting longer in the first place point to changes happening in the Arctic, where warming is occurring considerably faster than the global average. That accelerated Arctic warming shrinks the temperature difference between the poles and the equator, a difference that normally helps drive the jet stream. As that difference shrinks, the jet stream weakens and tends to wobble more, allowing high-pressure ridges to get stuck in place for extended periods rather than moving through in the more typical few-day cycle. The longer a ridge stays parked, the more energy and moisture accumulate beneath it, which in turn makes the eventual vacuum effect. Once that ridge finally breaks down, considerably more intense than it would have been decades ago under a more mobile, faster-moving jet stream pattern. This year's version of that volatility carries an added ingredient. A strong, possibly historic El Niño has been developing across the Pacific throughout the year, and forecasters have specifically flagged it as a factor capable of intensifying both the heat domes forming and the storms that eventually follow them. A stronger El Niño generally means more atmospheric energy and moisture available system-wide, which raises the odds that the vacuum left behind by a collapsing heat dome gets filled with something more severe than an average seasonal storm. Health officials add another layer of concern that tends to get lost once headlines shift away from heat. In the immediate aftermath of a record heat wave, hospital systems are often still managing a backlog of heat-related illness, from dehydration to heat stroke, even as attention moves to storm damage and power outages. People who were already vulnerable during the heat, including older adults, young children, and outdoor workers, frequently remain physically depleted in the days that follow, right when flash flooding, falling trees, or sudden power loss can compound an already fragile situation. Infrastructure feels this two-sided pressure as well. Power grids across multiple countries reported record demand during the peak of this summer's heat, as air conditioning use surged to unprecedented levels. Then, almost immediately afterward, storms arrived and knocked out power through entirely different means, felling trees and damaging lines already strained by weeks of continuous heavy load. That back-to-back sequence, one form of grid stress followed almost immediately by another, is part of why utility companies increasingly treat the collapse phase of a heat wave as seriously as the heat itself. So, what should people watch for once a record heat wave in their own region finally starts to ease? Meteorologists recommend paying close attention to any forecast language mentioning a pattern breakdown, frontal passage, or approaching low-pressure system, since these are the technical terms behind what eventually becomes the vacuum effect on the ground, a sudden shift in wind direction, a rapid buildup of towering clouds after days of clear skies, and rising humidity even as temperatures begin falling are all physical warning signs that the atmosphere is preparing to release the energy it has been storing. There is a financial dimension to this pattern too, one that rarely gets the same attention as the storm damage itself. Insurance claims tied to flooding, wind damage, and downed trees tend to spike sharply in the days immediately following a record heat wave, often catching insurers and local governments managing two separate disaster responses back to back rather than one. Farmers face a similar squeeze, having spent weeks protecting crops and livestock from extreme heat stress, only to then contend with flooding or hail damage from the storms that follow almost immediately afterward. That compounding effect, one extreme event layered directly on top of another within the same week, is part of why economists studying disaster costs increasingly treat the heat wave and its collapse as a single connected event rather than two separate ones. Officials also recommend a few concrete precautions during this transition window. Keep devices charged in anticipation of possible power outages. Avoid driving through flooded roads, since it takes very little moving water to sweep a vehicle off course. And treat the first sound of thunder as an immediate signal to move indoors, since lightning during these collapse-driven storms frequently arrives well ahead of the heaviest rain. The core message scientists keep repeating is a simple one, even if it runs against natural human instinct. A drop in temperature after a record heat wave is not confirmation that the danger has passed. It is frequently a sign that the atmosphere is about to rebalance itself, sometimes violently, as it fills the space left behind by days or weeks of extreme, stored-up heat. That rebalancing act, the vacuum being filled, is exactly the phase, scientists say, deserves just as much attention, if not more, than the heat wave that came before it. Before you go, if you want to stay ahead of these transitions as they continue to unfold across different regions this summer, make sure you like this video and subscribe, because we track exactly how these patterns develop in real time. The heat may be gone from the headlines, but the atmosphere is not finished responding to it. What fills that vacuum in the days ahead is, according to scientists watching it closely, very much still an open and genuinely concerning question. Pay attention to how forecasts describe the coming days in your own region, not just whether the temperature is finally dropping. A cool down paired with words like unsettled severe risk or pattern change is not simply good news arriving early. More often, it is the clearest signal available that the atmosphere is about to rebalance itself, and that the vacuum left behind by this summer's record heat is already close to being filled.